तो हेलो एवरीवन, कैसे हैं आप लोग। I hope I am audible and hello. Okay, so let's start. Share the screen, entire screen. Hello. Yeah. So I have I have seen problems with you guys. You people are running be it any code on the collab itself. like I just want to actually address this problem here right now, because I have seen in the community people are using the code only in the Colab. Colab is a great tool, no doubt, right? But it is not good for software development, right? It is good for data analysis and visualization or model training, right? Predictive modelings. So what we are covering in this session, from tomorrow onwards, we will be covering the Flask, we will be covering the face recognition. You cannot run those libraries in the Colab. Okay, so you better have a favorite IDE, integrated development environment, where you feel comfortable to write your own code, right? So yeah, that's what I actually want to clear out right now, because in the community people are just trying the entire code. Like, even I have shown the code into the Jupyter notebook and separately on the editor, but still some people are actually copy pasting that code into the Colab notebook. It will not going to work. That is why I showed you guys like how to do the how you can actually render an image with the on the Jupyter notebook with the matplotlib. There was a reason behind that. Okay, and why am I not using matplotlib with the editor? There is also a reason, because I feel much faster. But since you already have both of these approaches, you can choose either of those, right? But you should be clever about your choices, what you are doing, right? So that's what I actually wanted to say right now, because I am seeing people who are still doing mistakes, like editing, not editing, but taking the code from the file and putting it on the collab. It will not going to work. Okay, I just wanted to know you. I just wanted to clear it out to you guys, right? So PyCharm is fine. Yeah, any editor is fine. Like, you just need to have some sort of differentiation between which one to use when. All right. So yeah, that was just I wanted to tell you. And let's start the session now. Tembo. So in this session, what we will be covering is this is the last session of our what we can call basics. I wouldn't call it basics, because yeah, reading and writing is basics, showing the basics, but we have done a lot more than basics till now. But yeah, you can call it intermediate or basic, whatever. Okay, so in this session what we will be covering is the scaling part, how we can scale an image. Okay, scale. And then translation of an image. Sorry, my pen is not working right now correctly. Leave it. Scaling, translation, and rotation. Affine matrix, like it should come first, basically. Like, first we will going to see the affine matrix, then affine matrix, rotation, translation, then what comes after that? Image blending, that I actually mentioned yesterday, and afterwards convolution. These are the topics that we will going to cover in this session. Okay, so yeah, you better actually focus right now. Okay, let me wait, let me just erase this, because I don't find right. Okay, so what exactly the affine matrix is, like what exactly the affine transformation is. So you must have actually heard about the collinearity. What exactly the collinearity is, like we cannot put one we can this is actually these are actually known as collinear points, right? These are collinear. Why? Because each of these points have the same slope when you will going to draw it out. Okay, so each of these have the same slope. That is why they are collinear. When you will going to draw a tangent against every point, you will gonna get the same slope. So what does affine matrix do? It actually takes three distinct points, sorry, which are not collinear, and we actually project this this entire space, this entire 2D space into some another 2D space or some another Cartesian system, right? In the 2D system, obviously. But how this point can change, right? This point can change and this point can also change, but the ratio, like if the midpoint of this is x, the midpoint will not going to change, right? So this what actually the affine transformation does for us. So how exactly it is useful? Say say you have an image. Okay, this is the image, right? Now now you have actually seen, like in your phone, smart with the smartphones, when you actually want to shift this image to your right, how exactly I can do this? Like I can consider this as a 0 0, right? And what I can do, like I can just push this, let's say from 0 1, let's say from 0 1, instead of 0 0, let's say 0 1, because we do not know like it will be 0 1 or not. I am just making a hypothesis here. Okay, so let's say this is 0 1. Like into the from upper left corner to bottom right corner, I want to push it. Okay, but with how much pixel values? Like I want to add it. Okay, just focus on the words what I am saying. I want to add a pixel unit. Okay, so it actually what will going to happen, like when I'm going to perform this, okay, along with the 50 as well here, so what will going to happen? My image will going to shift slightly below here. We will going to see it in the action. So what exactly happened here? Okay, so if I have to put the affine transformation, so we what we need to do is we just have to perform a matrix multiplication. Okay, and then we have to do addition, vector addition. Sorry, right? My pen is not working, I don't know why. Vector addition. Okay, so this entire formulation of the process is your affine transformation. All right. Okay, so let's say you have a matrix called A is equals to, let's say either let's say here we have A11, A12, A21, A22. Okay, and we have a B matrix that actually shows the translation. All right, if you actually have to compare this with, this is your 0 1, which we are projecting to where 1 0, and this is your additional vector, which is actually translating your image space to one to basically projecting your image space to another coordinates. That's what it is doing right now. So we can call it B11, and this is B12. All right. Okay, so how can I actually represent my matrix for the translation? It's quite easy. I can just say it is AB. That's it. That is your matrix for translating an image. Okay, so what will I going to get in the last? A11, A12, B11, A21, A22, B21. All right, that is your matrix, and we still haven't actually translated it yet. So how can we translate it? We need a point. let's say we are defining a transformation matrix as this. So what we do is this: A, X, Y plus B. And as I told you on the first day itself, like, you should read about the matrix multiplication. Okay, so in the end, what I am gonna get is a11x plus a12x plus b11x if I actually solve this. But I like, it is quite easy. Okay, and this, for this, a21x, a22x, b2, sorry, a11x, a12y, and no, a11x, a12x, and b11x. Then this will be, I believe, y. Okay, so you will gonna get, this is your transformation matrix basically. Okay, so you can always calculate it on your own. You will gonna get the same answer. Okay, as we are. So that was your affine transformation. That is your transformation matrix. Okay, you can search it, like, it is quite an easy matrix multiplication. So what is happening right now, we are doing the matrix multiplication here, and we are adding a vector. This is your affine transformation. That's it. Okay, so let's see that in the code first. Okay, so let me just, okay, I believe it is visible, right? And please let me know, Josna, if it is not. Okay, I have now app.py. All right. So what I actually need to do, import, like, it must not be. Is it visible? Please let me know. Import, me. It should be visible now. Okay. Import CV2, and image will be CV2 dot IAM read. Okay. And where it is, images goku.png. Let me make sure that I have it. This, like, so what I'm going to do right now, Python app.py. If it is not returning any error, so I have the correct, yeah, I do have the correct image. Okay, so let's define our matrix. Okay, so since it's a 2D plane, right? Since it's a 2D plane, so what values are set, like, what value, what will be the domain of this matrix? Can anyone tell me in the chat what will be the domain of this matrix, since we are in 2D space? Even if we are in 3D space, okay, but 2D or 3D, what will be the domain of this xy or xyz plane? Can anyone tell me in the chat? Anyone? 2D? No, what 2D? Uh, okay. What will be the domain? Like, how many of you know about the domain? Maybe integers only. No, no. Minus infinity to plus infinity. Sandeep is right. Okay. So the answer will be here. R. Okay. That is how we define minus infinity to plus infinity. Right. And minus infinity to plus infinity also contains what? Float numbers. Right. Because it does not only contains the integer. So what we need to have cleared in our mind while we are defining our matrix, it should contain a float space, right? It should be in a float space. So let's actually define it. Okay. So I'm gonna tell, like, m is equals to, since we actually defined this as m float. Let's do this. So 0, 1, and wait a minute. I'm gonna have another one because it is not just 1, 0, 1, and 50. Let's just say 50, and 1, 0, and again let's just say 50. Okay, and I am not defining the numpy yet, so let me just define the numpy. Okay, and since now I have defined the numpy, what I need next is simple. So cv2 dot im show simple image, yeah, image. Okay, and afterwards what I need I need to actually, this is my matrix right now. Okay, that we have just studied right now. Okay, so what I need, like I can tell translated image cv2 dot, I believe it was warp affine, right? And what exactly warp affine does, let's just see what actually it takes. So if we have actually tap onto this, so you can see like it takes the source, then the matrix, okay, then it takes the d size, distance, and flags, etc., etc. Okay, so let's define the image. Sorry, oh shit, it got hanged. Image, and now we have m. Okay, and afterwards what we need is what the hell, d size, distance, 0.1, 0.2, source to distance. We have m now. Okay, let's actually try this right now, but we will be needing what, uh on what will be the center of this image, that we will be needing it. Okay, so what will be the width, since width, not width, by the way, it should be height, I believe. Width and the channel, it should be image dot shape. What I did here, let's just say, when you will run this command, it is nothing but the destructuring. Okay, okay, let's say, let's say I am having this array of 300 by 400 by 3. Okay, when I am defining h, w, and channel, an array, each value will going to have this. Okay, that's what I did here. So if my image shape is 300 by 400 by 3, so the height, basically the row actually makes the height, just don't get confused with it, and columns actually makes the width, right? So that is why I did the height and width here. And our translated image should have an origin, like where exactly the center of this image will be going to. Okay, and now what I need here is this, is height and width. Okay, that is your code. Okay, and let's run it. What, one type object had no shape, what the hell? Okay, I didn't have the images. Let's uh, goku.jpg. What the hell? Yeah, yeah. Image.shape. Hell, why my image is not? Wait a minute. Image. Why it is coming none? Okay, let me actually see if my path is right or not. Like it is images IMA GS. It is quite right. By object Python project OpenCV. Day images. Then I have goku.jpg. So that's what I have wrote here. Let's actually not waste time. Copy it. I don't know why it is not working, but let's just paste it here. Okay, so we don't waste any more time. Right, goku.jpg. Now we have this image. Let's see. Yeah. Okay, so np.float argument must be string or number, not list. Okay, so let's actually try to understand what exactly is happening right now. Okay, and fix this issue, like what we are getting. So what I am going to do right now, like I just can't remember the methods, like I have a volatile memory, as I told you earlier. So what I do, I usually just remember the concepts, how exactly it works. So what I do usually, I always go to the warp affine cv2, and I'm just gonna get into the documentation. Okay, and this is their explanation. Okay, and let's actually convert this into the Python, and we have this m here. Okay, warp affine source, that's what we are doing right now, but it is still not coming right. Okay, warp affine, warp mat, this is your image. Okay, but I am still not sure if I am getting the image or not. Let me just paste it, copy paste it here. Yeah, I am getting the image. Okay, so your n, so I need the matrix right now. Okay, so I actually created a better version of it. Let me just actually bring it here. Believe I gotta use this np.uint, not int but np.float dot s type, np.float 32. Sometimes actually this okay, must be float argument must be a string or number. All right, let's not waste time here. Okay, I have actually get it ready here. Python open c, what the hell, github. Mm-mm-mm. Okay, you can go here, profile, open cv, and tutorials. Like I took this session 2 years ago. So yeah, so image manipulation. I just no one can actually remember it. Okay, and nb dot viewer. This is my notebook, guys. Okay, okay. Let me actually see where exactly this is your. This is our transformation matrix, and this is what we are. Okay, my bad. Now I know where we are actually going. We need to perform here float 32 basically, and it should be gone now. Like okay, height and width, and that is what we are doing, right? Height and width, and now let's run it. Yeah, it worked. It worked. Okay, so let me actually perform this like the translated image. Okay, and this is your translated image, and cv2 dot wait key, when we will going to pass the zero here, what will it going to return? Like it will going to wait for the eternity till we press a button on our keyboard, right? So let's do it and wait for few seconds. It takes some times. Yeah, welcome guys, just wait. Yeah, it just came, right? So this is the image that we had. It got shifted from this to this, but I believe it also got rotated. Let's actually fix it. I believe it should be 1 0 and 0 1, right? Yeah, now it's fine. Okay, so now you can see like we just shifted this image onto the right corner, sorry, right bottom, like as I actually defined on this jam board here, right? Where exactly like how exactly we were going to shift it, that is how we did. Okay, here. Okay, so it was quite easy task to do, like not a big thing to do, and we can actually use this same thing how exactly in the rotation as well. So let's say I am naming the rotation matrix as rm, because why not, and let's say name it rotation matrix, and what I can get from rotation matrix is cv2 dot get rotation matrix and 2D. Why 2D? Because we are having a 2D plane. And again, what we need here. is, let's just see. Okay, we need a center, an angle, and a scale. What exactly does it mean? Like, with what center it should rotate, and what at what angle, and if it actually gets rotated, by what scale it should zoom out or zoom in. Okay, sorry, I think I actually made wrong hand gestures. Okay, so let's actually do this. So let's actually, rotate it on its own axis. So I'm going to tell height and width. Okay, and afterwards what I need is an angle, let's say for 90-degree, and let's just obtain the real size. Okay, and now let's run this code. Oh, my bad, I thought I did not, rotational matrix. And what we need now is the rotated image. So I'm going to rename as rotated image. Okay, and this will be your image height, and this is will be your rotation matrix, right? And yeah, height and width. Yep, yep. And then lastly, we have this rotated image and not translated, but rotated. Okay, now let's run this. And now we have rotated an image. Okay, but it got rotated onto the left side. Like you can see, it actually works on the counterclockwise. So it got rotated on the 90-degree on the counterclockwise. Okay, and let's actually fix this because I'm not liking the so what you can do, you can change the matrix, like the center, like matrix of the rotation here. Okay, so let's actually change not the matrix but the affine matrix we have. Not with the height and width by, like we can actually go with the height by 2, height by 2. That will be much better actually. Yeah, it is much better. Okay, so now you have seen, like I have rotated the image, I have translated the image, and I have also, this is also the original image. So we did actually rotation, transforming, translation, and what, but the scaling is still not has been done yet. Okay, so let's do the scaling as well. Again, easy task, scaled image. So what we can do, cv2.resize, it takes an image, then it takes what it does. Let's Okay, then what it does, like it takes the d size. What it means, like what should be the dimensional size of the scaled image. Let's say we have height divided by 2 and width divided by 2. Okay, sorry, it actually ran wrong. Resize sequence item with index as 0, wrong type. Okay, wait a minute. Think this is not, like it is not accepting right now the center. So what I am going to do right now, I will not going to accept the center, but fx fy, I'm going to give the fx and fy. Okay, this is your fx and fy. Just be with me, guys. Okay, so what I did here, initially it was actually asking for the d size. Okay, so what I would have done, like I would have again go into the documentation and see this, but seeing this, like, but what I used to like is this, like this manner. Say I want to actually scale, I want to remain, I want to actually intact the original x scale, but whereas I want to scale 2 times my y axis. Like height should be doubled, and your width should be as original as it was before. So let's do this, and that is your scaled image, and that is your again scaled image. Okay, and run this. So you can see, like it just got stretched out with what axis, y axis, right? So you can even stretch it out with the what, like x axis as well, like you can do it. So we will have a weird image. Okay, so that was your scaling, rotation, and translation. And now I will be taking the questions, because after this we will be delving into, we will be delving it with the image blending, It is quite a small topic, and after that the convolution part. Right. Let me see if we have not covered anything like what I have mentioned till now, like scaling, translation, rotation, blending, and convolution. Image blending and convolution is still there. Okay. Uh, any questions, please? Please tell me the solution. What solution you are asking, Akshita? Please let me know. Sir, I was trying the code, but it's showing me I am read attribute is not there in CV2. You there must be a typo from your R to the power n. Yeah, okay. All right. Yeah, I will be gonna get into the code for sure. Okay. Please explain the rotation part. Okay. All right. Let me actually brief about every topic or every topic that we have covered. Okay. So we have the affine matrix. So I believe like you people are somewhat comfortable with the affine matrix by now, right? That was your affine matrix. What we did, like, we just translated the image. Let me just brief you about everything again. Okay, so what exactly the affine did? Like someone is also asking me what exactly the 10 and 01 is doing. So say like this could be considered your 10, and like it is somewhat like a built-in coordinate system with the CV2 which actually comes along with it, and this can be considered as 01. That's what I did here, like 1001. So when you actually shift, let's say I want to shift 50 to where 10, right? So what will going to happen, my image will going to shift on the right bottom corner, right? So that's what I did with the translation part. All right. Okay. And now coming, someone is asking about the, I hope the affine matrix is clear or not. Like I mentioned there, like how affine matrix is helping us. Like I believe like you people know about the affine matrix. Yes, we can use like let me know. Like you can use the height and width as well if I remember, but I prefer that way because it is much more convenient to even remember. Okay. Sir, can we do all these by changing from the numbers in array in np dot float 32? We did only by that, Chaitanya. Fx and Fy are the height and width. Yes. For the scaling part, Fx is showing the what image width. Sorry, I'm just gonna type with the WID. And Fy is your image height. So when we are saying like just do the image of two times of width and three times of height, so the original image will be twice of the width and thrice of the height. Okay, so that is what I did there. All right. And anything else? I explained, Naga. Please explain the rotation part. Okay, Bhavna. So what exactly the rotation, what we need actually for the rotation, just assume with the perspective of physics, what we have a center to rotate something else. Like let's say you want to rotate this lever. Okay, so what you will gonna need, first you will gonna need a center. After that center, you will gonna need an angle. Okay, with what angle you want to rotate it. But since it's an image, you can keep this image. It's your choice if you want to keep this image as somewhat zoomed in or zoomed out. So that is what it is taking right now with the rotation matrix here. So it is taking, let me just copy this and paste it here. Okay, Let me just copy this and paste it here. So what it is, like, this is your center, this is your angle, and this is your scaling. Like, after the rotation, how much, let's say your image was like this, and after the, like, it was the dimension of 2 by 3. What will gonna happen with the rotation? Let's say it got transposed and the dimensions became what? 3 by 2, right? Okay, so rotation just happened, but now you may actually want to, scale the size of the image as well, right? So what you can do, like, you have the parameter for that. So you can keep it intact as original by giving it 1, and you can scale it out, or shrink it as well by it. It might not take like the negative value, I believe. No, it won't take, I think. It will not going to take, it can take zero point 0.1. So it will just gonna be more of a, lesser thing, and you might not be able to see it. Okay, wait a minute. I don't know, I haven't tried, like, okay, it's working really weirdly. Okay, oh, okay, my bad, my bad. I didn't check it out, like, wait a minute. Okay, that was your, so this is your rotated image. Okay, this is your translated image, and that is your original image. Okay, so it's still keeping up with the negative of 1, so with the, original size. But yeah, with the twice, it will just gonna be, zoom out a bit. You can see it yourself. This is your rotated image. Let me actually, with the rotated, let me just have the rotated image enabled only. That way you will gonna understand better. Okay, so now it has some sort of zooming out functionality when I just gave the 2 here. Okay, okay, right. When we had the minus to it, scaled on the different axis on the negative y, and when we are having the positive, it is scaling on the positive y basically. So yeah, that is what your rotation matrix was. No, angle can be anything. Angle could be 90 as well. Okay, it could be minus 45 as well, or minus 40 as well. There is no, hard and fast rule for it. Can be only 90. All right, sir. Can we resize the image frame? That's what we did with the, what, resize, cv2 dot resize. That's what we did with this. Uh, Came in here, text. That's what is for the resizing. Okay, this was for the resizing. All right. Any questions, sir? Can we resize it? Yes, we did. And scaling is basically zooming it. Yeah, but depends upon where, like in or out. How to decide direction plus for clockwise and negative for anti-clockwise? You just give plus or minus. Okay. For plus, it actually takes the counterclockwise, and for negative, it takes the clockwise value here. Okay. So for the negative angle, it takes the clockwise direction. Okay. And for the positive, it takes the counterclockwise. Right. If we want something after show image, what do you want, Anjali? Please be specific. Okay, cropping it. Cropping it, just I actually showed it in the cropping in the first session itself. Cropping is nothing but, let's me actually crop it. Like, this image can be cropped easily by slicing it. Let's say 100 image, 100 pixels, I just sliced. Okay, now I just cropped the hair of the Goku. That's it. That was your cropping. Okay, and anything else? How to resize motion image of that image? I don't understand your question, Ganesh. What do you mean by that? Motion image? Exactly what do you mean by that? A print statement. A print statement can be done anywhere. Sir, if you want something after showing image, yes, we can do print statement for that. Hello. Okay. So okay, all right. So that was your scaling and resizing, and what else? And we have everything like the rotation as well. Okay, and scaling as well and everything. We covered here like whatever we talked about. Any questions so far for me? So when general use of affine metrics in images, when you want to perform the translation, screen is blur. Is it still blur? Please let me know in the chat. On running it, I get only scaled image, not all, such as rotated normal means. Sir, it live class or recorded? It's live. I can speak. You can see like interacting me live right now with students. I on Mukhtar, I don't get your question. On running, I get only scaled images. How is it possible when you are not scaling it? How can I save it? I okay. I believe I actually showed you yesterday. What was it? What we can call it? I am right function. CV2 dot I am right. Okay, and let's say rotated dot JPG and rotated image. Okay, run it. Boom, boom, boom. There you go. Now you have the rotated image. Okay, what we actually you were asking about how exactly we can save it. We just did. All right, you can save it as well. Any questions? Then I will be moving to the convolution. Will I get any certificate? I don't. Yeah, maybe you will. Once, can you explain the syntax of wrap affine function? Wrap affine, where it is? Okay. Remember, like affine transformation, I told you earlier. What it does, it takes the image, then it takes the matrix. If you remember the affine matrix, A, B, and remember M is equals to matrix into A and B. Then I just showed like A1, A2, that was your M. Then afterwards the center of that image is as original image. So that is what I am taking right now. So the center will be 300 by 4, whatever it is, 300 by 400 if the image is 300 by 400. Okay, so the main of the center will be there. Explain the resize code again. Okay, Shriyanshi. uh, we have image here, and we are not taking any classes for like none is for basically defining a scale into the vector form, sorry, into the scalar form. I usually don't prefer it. So what you can do, you can scale out directly with these parameters fx and fy. All right. So what it will going to do, it will just going to stretch the width 5 times and y axis twice. All right, so that is what your scaling is, resizing. Right. Is this first class? No, it is your third class. And where can I get assignments? On the community. I believe I told you for the assignment yesterday. Like whatever we have covered till now, you should actually apply it on the video frames. Okay. None is zero. No, none is not zero. In Python, at least it is not. Explain the syntax of resize. I did, Shreyanshi. I did. Image, it takes the image. Okay, what image did we have? The original one here. Okay, and then afterwards I am stretching the fx, basically the width of the image 5 times and twice the image of the height. Okay, so fy is equals to 2. Right, please give written assignments. Okay, today it will be an assignment. Today it will be an assignment. I can tell you an assignment right now. Let's actually do the image blending. Okay, this is our last, I wouldn't call it last, but yeah, this is somewhat your translation topic, which is quite last right now. So let's do this. For that, I can have an what I can have an image downloaded. Let's say I want a background. Okay, I want a background, and let's say I like this background. Okay, save this. Back. background dot jpg, and I'm going to save it where? Project OpenCV day 3, and here background.jpg. And now let's see what will gonna happen. Okay, so let's actually do this in some other file because it is getting jargon now. And additive addition dot py, image addition to be specific. Let's rename this image addition, or blending also, you can call it, but okay. Let's say we are just remove it, import cv2, and I have an image 1 cv2 dot imread goku dot jpg, image 2 background dot jpg. Let's do something, added image 1 plus image 2. Okay, what will gonna happen right now? cv2 dot im show added image, weight key 0. Since this image has its own pixel values and this image has its own pixel values, but there could be a problem. Okay, let's just see what problem I can face right now. I believe there will be an error. Python image addition.py. Yeah. What it is? Ent and none type. Which one is none now? Background. I misspelled it. Okay. Yeah, I knew it. This will gonna happen. Why? Reason is the Goku's image is 300 by 400 and the background image is 600 by 100. So you cannot perform an addition on different dimension. It is true, right? Because the data will going to, dangling there, like the rest of the data where it will go. So let's actually search for 300 by 400 images because that is what we have right now. Okay, let's actually have this image, and it is still not 300 by 400. I don't know where I can actually get it. Let's actually do one thing. Resize it. Since we know about the resize now, what we can do, cv2 dot, sorry, resize what, image 2 as what? Uh, I want to resize this image as image 1 and image 2. Now I believe like I have to look for the shape of 0, image 1 dot shape of 1. Sorry. Okay, and that is why it is showing expected pylons. All right, now it is perfectly fine, and let's actually run this. Okay, 400 by 300. Oh my bad, 10. Yeah, we did it. Okay, so instead of actually doing that, what we did right now, you can see we just implemented, we just resized an image with the OpenCV. What we did, we took the image since the image dimension was different, and since we already learned about the resize method of the image, what we did, we just resized the width and column of it as we had with the our initial image. But when we are adding the pixel values of each image, it's something like it's quite horrible. Like I can't even fathom anything out of it. Like every value is getting much more pixelate. Like some values are approaching so much, what we can call it, 255. Some of them are like, I don't think like any one of these approaching 0, but Every pixel I can see is here like much more brighter. Okay, so how exactly we can control this? Since we just performed a simple addition, why don't we perform a blending? Okay, so let's actually do this. What we can do, blended image cv2 dot add weighted. Okay, so first what it takes is the image. It takes two images, image one, and then the alpha value, how much the value should be visible. Let's say I want to show the first image to be 70% of it, so I will gonna give the 70. Then the second image should be what, say zero point 0.3, sorry, zero point 0.3. Okay, this is it. And now what I am gonna do here is the blended image and blended image. All right, so when I am going to run this, wait a minute, in function add weighted, what it is telling, firstly, like missing required gamma. Okay, gamma, yeah, gamma, let's say gamma is zero point 0.1, let's say. All right, so now you can see like how much of a difference, like we still have that background, but the opacity, like but the the blending of the image has been isolated into proportions. Like I have 70% of the Goku and 30% of the background image. That is your additive image, right? And that is how you can even create your own backgrounds. Like that is basically the foundation of it. I wouldn't call it like the full-fledged backgrounds, of course now you can't, but this is where you can actually get an idea about how exactly it happens. Okay, and I believe I can increase gamma a bit. Nah, it's not working. Okay, you can actually try it out on your own. Like gamma should be the opacity value, I believe. Okay, I don't remember the gamma value what it does with the RGB channels or color space, but you can find it out on the Google for sure. Okay, but for the additive, there's 70% of the image. Like let's say I have completed 30% of the Goku's image and 70% of the background image. So background will be more prominent, right? So that is what is happening right now. Okay, all right, so that was your additive imaging. Okay, now comes the most fun part for me, basically, because that is actually convolution. All right, so do you guys have any questions till now? Contrast enhancing. Okay, yeah, maybe. The session is live. We can see it again on YouTube. Yes, size of the arrow of the image. Can we simultaneously resize image? How simultaneously you are asking? Like depends upon the code. Can you zoom the screen? It is not how, like I won't be able to code then. Where is the community? Why can't we resize an image to a negative value? Uh, how is it even possible? Just tell me. Yash, please give written assignments. Uh, what is gamma doing here? I think like it's the contrast or something, like as the Naga actually told, just written here. Okay, I don't remember because it was actually mentioning like the gamma should be, should be here. So we can actually always Google it out. Gamma and color space, color correction. So what it is basically used to decode the luminance basically. So I don't remember how exactly it works honestly, and I don't really want to give false information here. So you can always check it out on your own, like how exactly a simple parameter is doing. Okay, and now what I actually can tell, like whatever we have covered till now, it is also applicable on where, like on the video part as well. Okay, so when you actually, I want what I actually want from you guys, like you can actually consider this as an assignment right now. So what I want, I want you to create a file or a Python script, okay, where you have 6 backgrounds, and when you put one, then the background should change on the real time of your video frame. Okay, so you will be having 6 backgrounds. You can choose either of the backgrounds. Okay, 1 2 3 4 5 6, and the video should be on the real time. When you press one, the background should get changed. When you press two, there should be another background. So you will gonna get a feeling of using somewhat like you have used the what we call Instagram, right? So that's what actually Instagram does. Like when we press something, the background gets changed. So same functionality with the foundation that we have covered till now. You have to cover it. Okay, that is your assignment. What I have just told you. I will I will also going to write it about something, but that is what I am going to give you as an assignment. Okay, how to do it as a video? It is your assignment, Subha. Okay, I just mentioned yesterday. You can actually refer to the yesterday's session, how exactly I use the video. And after that, you have to perform the image edition, like the blending of it, what I just did here. Okay, that is your assignment. Okay, you have to perform 6 background filters on your live image, on your live video. All right. I am getting an error in video part. What is the error? Please post it in the community. Like I am active there now. Okay. So whatever the error you have there, like in the CV2 or anything in the session, please post it there. Already share on the community. Okay. Please tag me there then. All right. I will look into it. So now comes the last and the most interesting part for me at least. What it is, sir, webcam is not there. You must be not accessing it rightly, Uday. Can we add image and video using add weighted? That is what your assignment, Venkat. Sai Harsha, sir, we have to perform this for a frame of video because it is taking a lot of memory while dealing with the videos. Yes, it might take, but it has to be figured out by you. Like I will be actually checking out. Like please tag me there by completing your assignments. Okay, and what I can do for you guys, like I don't know. Like I will just gonna give more of the resources where you can learn even after the 6 days of this session, and you can enhance your open CV and computer vision skills. Honestly speaking, computer vision is a vast field that actually comes under the deep learning. All right. So whatever we are covering right now, like the next topic is the convolution. Sorry. Let me actually have some water first. The next topic is actually the convolution, and uh, it is actually a CNN part where you actually convolve over an image of array, and you get a new array with a new dimension. All right. Okay. So what is convolution basically? Let's actually try to understand this. Say we have what the hell? Say we have an image right now. Okay. And since this actually consists of some pixel units, right? So on and so forth till xn, x1n, oh sorry, xn1, right? It should be one or two. Yeah, one, xn2, okay, whatever, till there. Okay. What we do a matrix operation or convolution operation. Okay. How exactly it goes? We take a kernel. Your kernel is nothing but a new matrix now. It could be any size, like 3 by 3, say, and it could be n by m. Let's say let actually, just for the sake of the simplicity, let us actually take it n by n, right? And now and this kernel value will gonna have some values, not the pixel values, some values based upon the blurring, outlining. Like there is like there could be an identity matrix, and you do realize what exactly the identity matrix is. Like it is 0 here on the diagonal elements, it is 0, right? That is your identity matrix. And what exactly the identity matrix does, it doesn't affect the original image. Okay, so let me actually get back to the convolution part again. Okay, so what we do during the convolution, we convolve this kernel over every size of this image. Let's say you have a kernel of 3 by 3 here. Okay, and now what I want to do, this 3 by 3 will going to convolve over these 3 by 3 means 9 values. So first from here to here 9 values. So these 3 by 3, so a11, let's say a11, if it actually starts from a11, so a11, a12, and a13, a21, a22, a23, right? A31, a32, and 33, right? This particular portion will going to have a element wise multiplication, and this operation will going to yield us a single pixel unit. Okay, a single pixel unit. And then again it will going to move forward only one column, then it will gonna convolve over those 3 by 3, then again will going to slide further. Okay, just one column, then going to move, then again it will going to come down. Okay, and then and the you will gonna get the value, a new matrix of image, a new array of the image. All right, and the dimension, usually what how exactly we calculate the dimension is this formula. Let's say you have 300 dimension, 300 by 300, that is being convoluted by 3 by 3 kernel. So the dimension that you can tell is n minus k plus 1. All right, what exactly the n here is? 300. It is more to do with the input layers, but I really don't want to get into this. So 300 minus 298. So your last convoluted image shape will be 298 by 298. All right, sorry. Okay, so let's actually see that in action. Actually, setosa.io. Okay, that is actually a visualization. Setosa.io image kernels. There you go. Say you have this image. This is the entire image. Okay, and I don't know if you can see this or not, but guys, like this is the website name. Okay, satosa.io ev dot like image kernels. Okay, this is it. So what you can see here, like every pixel unit, like right, every pixel unit, like someone is 244, and the moment you actually go on the darker one, let me just zoom it out a bit. The moment you actually go into the darker one, let's say 31, it becomes dark. Like you can see that here is dark right now here. Okay, and for this is again dark, but for the whiter one it is 255, right? So that is your as I actually mentioned earlier, like I have been mentioning again and again, the image actually gets where to where, 0 to 255, right? So let's actually perform a kernel operation here, like the convolution. So the image is the operation is the sharpening. Okay, we will just going to sharpen the image, and that is actually a predefined kernel, like that what researchers must have actually came up to, and that's what they actually do, like that's what they actually use right now, right? And let's actually perform a 3 by 3 kernel here. So 3 by 3 convolution here, like you can see for 3 by 3 I am getting on the top right, like here. Okay, like a single pixel unit. And what exactly that pixel unit is saying, like the entire being a dark seeing right now is a dark pixel unit on the right side. And as I go forward, I you can see like the operation is happening. Okay, so that is how a convolution works. Okay, it is actually a very broader topic if we will talk about, like the neural input layers, then the hidden layers, how exactly the every layers goes into, then what actually spits it out. But it is actually enough for giving you an intuition of like how exactly it works, right? So that is how your convolution works. Okay, and now you can actually play it as well, like blurring it. You can blur it as well, and you can see like we just blurred it. And right sobel. Okay, you just have to actually learn about these, like right sobel actually a mathematical, I believe, algorithm. Sharpening, we will gonna go get into the sharpening by ourselves. Okay, and yeah, that is it. Okay, so let's actually try this on our own now. Okay, so what I'm gonna do now is this. I'm just gonna create a new file. What I'm going to name it like con.py. Import cv2 image cv2 dot im read, which is goku dot jpg, right? And now what I need is, let's say, kernel, right? So I'm going to name it kernel. Sorry. Np dot, let's say, float, not float, but let's say float 32. And let's give some values, 1 0 0 0 1, sorry, 0 1 1. We're gonna actually add something more to it. Let's me just structure it a good bit. 1 1, and let's say -5. I just took a random kernel, that's it. Okay, and import numpy as np. Of course we have to do this afterwards. And what I need here is filter. Basically it is actually a 2D operation. So what we will gonna need is conv image cv2 dot filter 2D. So first thing that we need is the image. Second thing, it's actually an anchor point. Okay, so -1 and kernel. And let's just say cv2 dot im show convoluted image conv image cv2 dot weight key 0. Right, and let's run this. Now what it is, con.py. It might take some time. Okay, meanwhile let me actually read about something, some of your comments. The screen is stuck, is it? Let me actually see it. Not really. So lagging, is it still lagging, Josna? So now you can see like we have a convoluted image. Okay, sir, explain again. The can't see your screen changes in the. Okay, all right, all right. Okay, let me actually explain again. So I actually took a random kernel. Okay, and most of the values are, you can see, like approaching 0, right? And negative values. Okay, so the addition will just gonna make our image more darker if you actually see this that way, right? So that is what will gonna happen. And since we are not amplifying any of the pixels with the larger units, so yeah, so let's actually do this. And that is how you actually define it. And this is actually your d depth. Okay, and I actually figured it out, like I also stumbled upon like how exactly it is, this -1 works. They call it as an anchor point where exactly your image, should be there. But yeah, and let's actually run this, and that is what your image is basically. Okay, so that is what you actually have to pass in order to run a convolution. Like I tried doing giving it like -2, but yeah, like the depth actually gets decreased if you actually see this, like the anchor point of it. And let's actually try to increase it by 100. So yeah, it might have some problem then, like yeah. Okay, so it just got decreased. Okay, so the depth actually got decreased. So what we actually do is like -1. That's what I actually used to do, if I remember. Yeah. Okay, so that is actually how your convolution works. Just for the ones, ignore the -1. Okay, and what I am doing right now is just performing a simple convolution with this kernel. All right, over what? This image. Okay, and the result I am getting is this. All right, let's actually make it somewhat brighter. And 100, 120, 111. Okay, now it will be much more brighter, I believe. It became more so much brighter. Okay, uh, let's actually do this with like 20, 20, 50, 30, and 25. Okay, you can see right now, like as I actually saw this there, like we saw it here. The more the value we have, like it depends upon the convolution value, like zeros, what actually it's being multiplied to a single pixel unit. So you can see, like right now we are multiplying zero, so it will just gonna get zero. So whatever value we will gonna have, like, so the value will be 253 for this, to 178 for this. So that is how your convolution is working. Okay, and yeah, that was your convolution. So any questions? Let me see. So, what does one represent? Convolution is done on binary images. Convolution can be done on any images, Naga. Okay, like what we are doing, it is actually an RGB image. If you see, right, it's a colored image. Okay, and I just performed convolution over a colored image. Right, so convolution can be happen on anything. There are many things that are like, there are two types of convolution for sure: 2D convolution and 3D convolution. What we performed was a 2D convolution. All right. How to choose different kernel matrices for different operations. It's a whole topic to be discussed about actually. Like there is a blurring, there is a smoothing, there is a Sobel method, there is also a binarization, Otsu's binarization. Okay. So yeah, this could be actually out of this scope. And since we will going to cover up what we can call it like okay, what we can call it like face recognition tasks mostly. So I believe this is the foundation that you need to actually cover up everything. Okay, so that is what you need right now. Okay, filters. Okay, okay, all right. So yeah, so let's actually, someone actually asked me how exactly we can do this with the image, like the image addition with the video. I am just actually showing you, like I have around like 5 or 10 minutes more, so I can tell you how exactly it can be done. Right. Okay, but I won't be actually pushing that code to the GitHub. All right, you just have to come here and again see it. So let me actually come in here, open my CD. uh, can do like touch demo.py, source env bin activate, and sublime. I'm gonna use sublime here. Okay, okay, I believe I have sublime open. Let's go into the demo. All right, and demo.py. Right now, what I'm gonna do is import cv2 capture cv2 dot. Uh, Let me actually. I have to actually, leave the class for once, and I'm just gonna come back again. Okay, just in 1 second. Okay, so I can actually use my, what I can say, like, camera. So I'm just gonna ask it default. Okay. No, I really don't have to actually go. Okay. Please let me know if everyone can still see my screen or not. I believe you can, right? Yeah. Okay. So let's do this. CV2 dot video capture 0 while, sorry, while true, flag and frame cap dot read, if not flag, print could access the webcam. Okay, and afterwards should get break, and after that I have like background image as well here, right? Downloaded. What is downloaded? Okay, that was me. Sorry. Okay, so but I have Goku as well. Okay, so I'm gonna blend this image on myself. Okay, so let's do this. So how exactly I can do this? I have this frame which I am reading right now. So let me actually start it. Okay, and yeah, so image, and what exactly it should be blended to, blended frame cv2 dot add weighted. What it takes is the, sorry,
Excuse me, sir.
yes.
Your screen is not visible.
Oh, I, sorry.
Yes, can you share it again?
Yeah, 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 I'm sorry. Okay, now is it visible?
Yes, sir. Now it is visible.
Okay, okay. So that was your video capture. Okay, I we have already seen this. Okay, initially. So it is nothing new, but we saw the add vetted method. Okay, so what I am gonna do, I'm going to read the image first. This is my image, cv2 dot I am read, and I have Goku dot what, png. Okay, and afterwards I want to add my frame to be point 0.8, let's say, and the Goku's image should be at point 0.2, and the gamma should be point 0.1. Okay, and now cv2 dot I am show uh, blended frame, blended frame. Okay, and now if cv2 dot wait key, like let's say for 10 seconds, and bit masking of odd of 2, this should actually came out of this loop break. Okay, and what I need to do, cap dot release and cv2 dot destroy all windows. That's it. Let's run this. What happened? Array or op scalar. What happened? Just okay. Resizing problem, I believe. Right. So our image should again, like, image should again get resized. Resized. Uh, frame dot shape of what, 1, frame of dot shape of what, 0. Okay, now it should work. Sometimes it take times. Okay, so please wait. Oof. Initially it takes time, so you can see right now, like I am like on my video frame, I have Goku embedded right now, and I am also, uh, available real time. So this is what you actually need to do. Okay, but with the six different backgrounds, all right, that could be a total background program for you guys. So you could have a mini project where you actually created a filter method. Okay, with that, and yeah, okay, and that is it. So I just showed you how exactly, and you can do this. Okay, search screen is stuck. Now it is visible, I believe. Okay, okay. Assignment. I just told you assignment. Okay, and still in the community group, you can actually go into my post where I will be mentioning the assignment. Okay, can we do convolution to two videos? Yes, we can. Of course, we can, Sahi Harsha. Kunal, we have to use switch case for each background. Yes. And the funny thing is, Python just introduced switches. Okay, try it. Okay, you might actually learn something new. Here the image is the foreground. Yeah, it is actually. Yeah, it is actually. So what you can do is this. You are right. What you can do is this. And when you will gonna run this, yeah, wait a minute. I think this has to do with the gamma. Okay, wait a minute. The more it is, but the foreground. Yeah, but uh, okay. Image. My frame is having around, like, let's say it should be zero point 0.8, and it should be have opacity. I think this is actually opacity. Yeah, this is actually the opacity value. Okay. So again, you can see like it is being rendered here. Okay. So yeah, try it out. Okay, but with the different backgrounds, like different foregrounds. If it is foreground, then you can actually use a different foregrounds. Okay, so I believe the background actually comes along with the bit masking, which we might not cover. Okay, like if I happen to have some time tomorrow, I could actually give you a brief about it. But yeah, it actually comes under the bit masking. To you take a portion of an image, you paste it into your own image, like that's what how it actually happens. Okay, so yeah, we will let me actually, yeah, we can actually cover the bit masking as well tomorrow. Okay, and then afterwards I am just going to we will just gonna get into the face recognition, face detection, and by the end of the sixth day you will be having an application which can actually detect real time faces, if it is you, if it's someone else. Okay, and you can use it in your projects. All right. Okay, any more questions? Any more questions? Okay then. Okay then. So I think if you guys don't have any questions, even if you have questions, please tag me in the community group. Okay, in the community I will be there. Can we use two videos at a time? uh I haven't actually tried this myself, so I can't answer it. Assignment is the only on the live feed or any downloaded videos. You can actually do with the videos as well, of course. Sir, sir, is your UG and PG courses, sir? I don't know about it. Like, sir, is your UG or PG? It's just a simple essentials, right? I don't know. In today's assignment, we have to take six backgrounds to take input as one of those. Yes, sahi hai, Shah. Yes. Can you check error in community? Yes, I can check the errors. Sanjana is asking, what is the frame dot shape? All right, Sanjana, let's say the shape is 300 by 400. Like, what exactly the image dot shape actually gives you? It gives you the shape of an array. So if you have 300 by 400 by 3, basically 3 is the channels. So you can literally destructure those values. Like, when I am saying image dot shape 0, I am accessing the value of 300. When I am saying 1, I am accessing value of what? 400. And for 2, it's 3. Okay. What are the course you studied in the UG and PG? I haven't, you know, okay. So you are asking about my academic qualifications. I am an information technology, engineer, IT engineer. So that is what my UJ is. I'm a bachelor of engineer, like bachelor of information technology engineer. Okay. So can you link your Let's Upgrade profile here? Uh, it's Gopal Singh, I believe. Let me actually show you guys where what my name is. It is. This is what it is. Okay. I hope you can see this, right? Yeah, it is. So this is what my profile is. Okay. So data guy 404. Data guy 404. That is what my username is. All right. And I even posted something else. Like, I was just trying. Oh, I have 7 followers. All right. So yeah, that is what my name is. Like, the bio is doing multiplication, and the bio says oscillating between joy and sorrow. Right. So yeah, that is me. You can tag me there. Okay. So that is it for today, guys. I hope you learned something new, and I wish you good night and goodbye.